So in this video, we learn how to find the kernel and range of a transformation. Now in simple terms, kernel of a transformation is such that t of x transformation of x is equal to 0. And that's it. So in this question, if we are to find the kernel of t of x and y is equal to x plus 2y comma 3x plus 6y. So the first thing or the first step that we do is write this in the augmented format, augmented matrix format. And that is simply the coefficients of x and y over here. So the coefficient of x here is 1 and the coefficient of y here is 2, and this is in a matrix. Now the coefficient of x in the second pair is 3 and the coefficient of y here is 6, and that's it. So x and y, you can just write that on the top if that helps you, but you don't need to. And now all you need to do is equate this to 0. As we mentioned before, t of x is equal to 0. So draw a line here and equate it to 0. And now we just need to find the RREF of this matrix, which I have made a video on how to find the reduced row echelon form, or RREF as short form. And let's do that. Simply, all we need to do is we need to find the pivot in each row, and there cannot be any zeros below it and above it. So here our pivot has to be 1, which we do have, and we cannot have a number below it and above it. So we do have a 3 here, so we can use the following row operation to get rid of the 3, which is minus 3r1 plus r2 is equal to, or let me, yeah, so the first row stays the same. We are only doing the operation to the second row over here. So 1, 2, and then 0. And here, what is 3 minus 3 times 1 is going to be 0, right? Since we're trying to get rid of this 3. And here, 2 times 3, which is 6. And then you do 6 minus 6, which is also 0. And then for the last column, we also do this, but we have a 0 here. So that's also going to be 0. Now close the brackets. Now remember, this was x and this was y, right? So here 1x plus 2y is equal to 0, or you can write x is equal to minus 2y. And if you want to write it in the matrix format, that is gonna be, since x is equal to 2y minus 2y, basically the y here is a free variable. So let's write it in the matrix format now. X and y is equal to, x is equal to minus 2y, so minus 2y, and y is equal to y itself, right, since it's a free variable. So that's it. And if you want, you can factor the y outside over here. Actually, you're supposed to write it before this. So y into minus 2 and 1, where y is any real number. It's a free variable here. So now let's move on to our next question. So here, pause the video and try to do this example yourself. So again, let's write the augmented format, augmented matrix format. The coefficient of x and y here is 2 and 1, and then here it is 1 and minus 1. So it's going to be 2 and then 1, and here the next one's going to be 1 and minus 1. So in this question, I'm going to show you two methods, the same method as before to do the first method. So let's equate this to 0, 0 and 0, and let's do minus 2r2 plus r1, and this is going to give us 0, and then minus 2r2 is going to be 2 plus 1, which is 3, and then the down stays the same. Oh, my bad, this is supposed to be minus r2 only because we need a 1 up there as a pivot. So my bad, it's going to be minus r2 plus r1. This is going to be 1, and this is going to be 2, yeah, and here is going to stay the same now, and the zeros are going to stay the same. Now let's do r minus r1 plus r2, and this will give us 1 2 0 1, and we can get rid of this 2 now. We can just do minus 2 r2, and then this won't make any other difference since we have a 0 here and 0 here, so I can just directly write 0 over here. And that's it. So you realize that each of the columns is independent on the other, is independent basically, is linearly independent. And by that I mean, in each column there is only an x or an y, and we call that linearly independent. Now the shortcut method that I was talking about, if we go back to this matrix which was 2 1 1 minus 1, and we find the determinant which is a times d. Let me write the a b c d. A times d minus b times c, which is here is going to be 2 times -1 -2 minus 1, right, which is equal to -3, and this is not equal to 0. So if you don't get an answer, if we don't get the determinant as 0, we can directly say that this is linearly independent. And here basically we have x is equal to 0, y is equal to 0, right? So basically the kernel is 0. Since if you want to write it in the matrix format, it's going to be x, y is equal to 0 0, right? That's it. And this is another method. If you calculate the determinant, and if it's not equal to 0, so any other number other than 0, -3 1 2 3 whatever, you can directly say that the kernel here is equal to 0, or x and y is equal to 0, like this. Now we need to find if 3 and 0 is in the range of t, right? So what kernel did we get? We got this as a kernel, right? 1 0 0 1, 1 0 0 1, and then put the line, it's going to be 3 0. And basically what we need to do is we need to see if the matrix that we got in the range is consistent in the transformation. So if you look at this, this is x plus 0y is equal to 3, or 0x plus y is equal to 0, right? Which looks pretty consistent, as you can have an x value here and get 3, so x is equal to 3, or here we can say that y is equal to 0. Now let's look at an example where the range is not, the matrix is not in the range. So by that I mean the equation that we get here is inconsistent. So let's just change this to 1, and let's change this to 0. Now the first row says the same, so let me erase this, and in the second row we have 0x plus 0y is equal to 1, which is undefined, or let's say inconsistent, right? Since we cannot have a 0 is equal to 1, right? So this is what I mean by inconsistent. But in our question we had 3 0, which is consistent in the range. And another shortcut method for you guys, if you get that the kernel is 0, meaning that the columns here are independent, you can realize that you always have a 1 in either x and y, right? So you will always never have inconsistent, since even if you have 0 here, it is possible that x is equal to 0, so x here is 0, right? But if you have, let's say, 1 0 0 0, then yeah, you can have an inconsistent range, right? If this is 1 or 2 or any other value. So that's another thing to keep in mind. So again, the range is simply finding if it's consistent, and if you have the kernel equal to 0, you can directly say that the columns are independent, linearly independent, that any range, so that means any range is in the range, any matrix, sorry, is in the range. And let's move on to our last question. So now let's do our last question. So again, pause the video and try to do this example yourself. Now let's find the standard matrix first, or augmented matrix, which is the coefficients of x and y. And here you need to be careful, since in this question, in the second pair of x and y, we have minus 10y plus 5x. Even though they shuffled the order, you still have to write the x coefficients first, then the y. So here is going to be, the first pair is 2 and minus 1, since the coefficient of y here is minus 1 and coefficient of x is 2. And then we have 5 first, don't get confused, and then minus 10. So we have the standard matrix now. Now actually let me add another question here, just a quick one. You might have this. They might ask you to ask, the projection. Let me actually write it first. So the question is, let's call this B. Projection on the x-axis applied on the standard matrix. Now this is our standard matrix, and the projection on the x-axis is basically multiplying the standard matrix by the matrix of projection on x-axis, which I did make the video, so you can check it out. We have some standard matrix that we need to memorize, such as projection on x-axis, y-axis, reflection on x and y-axis, and the last one was some other operator. So you need to remember these matrix also. So the projection on x-axis is just basically 1 0 0 0, and we multiply this and we get the answer for B as 2 minus 1 0 and 0. And if you don't know how to multiply matrices, it's a row by column, and then again the second row, or sorry, the first row by the second column, and then you move on to the second row, and then first column here, and second row and second column. And this is the answer for part B. Now let's do part A, the kernel, and let's use our shortcut method of the determinant. So it's going to be 2 multiplied by minus 10 minus, and then plus, since we have another minus 5, so this is going to give us minus 15, which is not equal to 0. So here we can directly say that the kernel is equal to 0. So x, or sorry, let me write it over here, x y is equal to 0, or let's say 0 0, like this. And sorry to mention this, you have to write kernel, actually remove all this, kernel is equal to 0 matrix or vector. You can't write 0 like that, you have to mention that it's a vector. And our next question we have is 1 minus 5 is in the range. And as we mentioned before, we said that if the kernel is 0, meaning that each of the x and y are independent on each other, we can have any matrix in the range, right? So here we can directly say that B, or sorry, let me remove this. Question B, since the columns are independent, linearly independent, sorry, or you can just say that since kernel is equal to 0, any matrix in R2, basically meaning that in this dimension, since this is a transformation equals to R2, so we have two dimensions, right, x and y. If we had 3, it would be x, y, and z. So in R2 is in the range, basically, and that's it. You just need to mention any of these reasons. So each column is linearly independent, or the kernel is equal to 0, which is more simpler, I guess. And that's it. So if you have any questions, you can ask them in the comment section. I'll be more than happy to answer. And thanks for watching.